Okay, so in question number 9, the school newspaper claims that 60% of the students at a large school did all the assignments last week. AP statistics students were skeptical, so they choose a simple random sample of 100 students and they interviewed them. Now, the value of p-hat may vary from sample to sample. What if we start with the assumption that exactly 60% of the population really did do their homework? What if we then did a simulation of 100 students at a time with that assumption? We have a piece of software called Fathom that allows us to do those simulations, where we can say, here's a really large high school, skim off 100, see what the proportion is. Skim off another 100, kind of like what you did with those poker chips the other day. What if we did that again and again and again? What if we did 250 simulations of 100, a sample size of 100? Well, we get a distribution of a bunch of p-hats. All right? Now, that histogram is that distribution. And then what we have is what? Is this a sampling distribution of p-hat is the first question in here. Answer. No. Okay, now, what's the difference between this bunch of p-hats that came out of these simulations and the true sampling distribution? Answer, the word all. Our definition of a sampling distribution is the distribution of all the different values a statistic can take on from every possible sample. Did they do every possible sample? They did a lot. They did 250 samples, but is that all possible samples? Answer is no. So is this a sampling distribution? No, but it's a good guess at what the sampling distribution would start to look like.
But how do you know they did all?
How would they know they did all? Because let me do a for instance. Okay, now this is sample size 100. All right. How many samples would it take to do all possible samples of size 100? And I'll make it easy, out of a high school with 1,000 people. Right? And the answer is, that number is 100 times 99 times 98, all the way to 1, which we commonly know as 100 factorial. Oh, I'm sorry. That is not right. Let me try that again. It's actually an easier question to answer with the tools that you have at hand. It's 1,000, choose 100. Can someone quickly do that on the calculator, please? Remember where that is? You put in 1,000, math, PRB, and then there's a thing that says NCR, and then you put in the 100. Can someone tell me what 1,000 choose 100 is? Overflow. Overflow. This number, 1,000 choose 100, is greater than the largest number than the calculator can store. It's larger than 10 to the 99th. It's larger than a 1 followed by 99 zeros. So is 250 all the possible samples? No. These numbers get really, really big really, really fast. Right? So even if we did 100,000 samples, we're still nowhere near all possible samples. So the answer is no, but it is a reasonable guess at what the sampling distribution is going to look like. All right. B, describe the distribution. Are there any obvious outliers? Well, wait, we got to do all of the things if we're going to describe the distribution. Where do we think the center of this simulation is? About 0.6, right where the population proportion is? Sure. Okay. Symmetric for its shape. Okay. Hard to talk about the spread without actually crunching some data, so we'll avoid the spread. Is there any obvious outliers? Yeah, I think down here is an outlier. I think up here is an outlier. So when you have a population of 60, sorry, when the population proportion is 60%, numbers like, 47%, numbers like, I don't know, 72% are starting to get into the outlier area. Okay, great. So now we get to the meat of the problem. Right there, problem C. Suppose that 45 of the 100 students that actually took the survey said they did all their homework last week. Remember, the claim was that 60% of everyone does their homework. Now, they did a sample of 100 people, and they only got 45 people to say they did all their homework. First of all, 45% or 0.45. It is a statistic. It's a number that's coming from a sample. What do you think about that number? What is that, Jessica? It certainly doesn't seem to fall in this distribution. Here's 45 right here. I would say that number would be a really rare outcome, assuming that really 60% of the people do all their homework. What do we call it when something is so rare that maybe the 60% isn't a good assumption? I would call that, what was that, Michael?
Statistically significant.
Statistically significant. I think this is a statistically significant result. I think that this result is so out of whack with what would happen by pure chance alone that something else is going on. Answer, what's going on really? It's not true that 60% of the kids at this high school are doing all their homework. That claim, I think, is false. More on that later. All right. So in question number 11, going back, referring to exercise 9, make a graph of the population distribution given that there are 3,000 students in the school. What type of variable is getting measured? Now, this question came up because there's a typo in your book that is not in my book. In your book, it doesn't say 3,000, it says 300. Right? And so in the answer key, the scale for this is that if there's 60% of the students doing all their work, the number of people who would say yes to this is going to be something like 1,800. And the number of people not doing all their homework is going to be something like 1,200.
That's just 60% of 3,000.
60% of 3,000, yeah. All right? But in your book, if you use the assumption of 300 students, it becomes 180 and 120. So if you saw that contradiction, there's a typo in your book. All right? But let's get to this last question here, because this is actually the most important question, part of that question. What type of variable is being measured? Because someone asked me, because we started talking about, I'm going to talk about the distribution of X bars and the distribution of P hats. When do we know we're going to use one or the other? Well, let me ask you the question. What kind of variable did you do all of your homework last week? That's a yes-no question. It's a categorical variable. Okay? Here's what I want you to start putting together in your mind. When we are measuring categorical variables, the typical way we measure it is in proportions. So when we're in categorical variable land, we tend to live in the land of P's and P hats. When we are in quantitative variable world, like height, weight, hair length, beard length, those things tend to get measured with averages, with means. That's the world of mu's and X bars. Categorical, P's and P hats, quantitative, X bars and mu's. All right? Let's finish this question off. Sketch the possible graph of the distribution. Yeah, we just did that. All right. Oh, Sketch a possible graph of the distribution of the sample data of an SRS of 100 taken by the AP Statistics students. Oh, that one, the AP Statistics students looks like this, right? 100. How many people said yes? 45%. How many people said no? 60%. Here's the graph for the AP Stat students. Are we done with problems 9 and 11? Have I thoroughly bored you on that? Okay. All right, I'm going to close off this recording and then we're going to go to problem number 17.